So within experiments, we have a lot of terminology and lingo that we'll use. We've seen a couple of these already. So experimental units are the things being given the treatment. And like I said, you want to be very careful here. Sometimes our experimental units are different than our observational units. So thinking about the CT program. For the CT program, the experimental units, if they actually did it as an experiment, the experimental units would be the classes themselves. The way they actually do the CT program is instructors who want a CT have to go through a training, and then they're eligible to have a CT. So those instructors who are willing to go through the training tend to be very different than the instructors who are not. So the CT program is not an experimental design by any means. The next piece of terminology is factor. So, and in fact, we have a bunch of definitions at once. So we have 3 different definitions for factors and 3 different definitions for responses all at once. And basically this is that we think there is some variable, which we'll call an explanatory variable, an independent variable, and we'll also refer to in our experimental lingo as a factor. We think that this influences some response, right, or some outcome, or some dependent variable. Right? So we might think that having a CT influences success, whether that's GPA, whether that's grade in the class. That's the idea, right? That this is the explanation for what is happening there. And again, with an experiment, this is the only time in statistics we have the ability to use causal language, because as long as our experiment was well designed and it was randomized, we can say that whatever the heck we manipulated was the reason for the difference. We can't say that with observational studies. The levels would be the specific values chosen for a factor. So in many situations for our factor, it's just like yes or no, there is a CT or there isn't a CT. But if you thought back to like maybe the salt study, maybe they want to give people high salt, moderate salt, low salt. Maybe there's 3 different levels of salt that they're going to put into the different meals. Or maybe it's just 2. Maybe it's the recommendation and maybe it's slightly extra. Who knows? The treatment is a combination of whatever these factors might be. So it may be that we're manipulating more than one thing. We're not just interested in whether the CT has a difference, but maybe we have a CTs and we have embedded counselors. So if that's the case, we'd have 4 different options. CT with an embedded counselor, CT, no embedded counselor, no CT, and neither. So all of these would be the actual treatment if we were trying to see how maybe those 2 things were like influence one another as well. Is there an interaction? Are students better off with just one, or are they better off with both? Who knows? So if there's more than one factor, your treatment is that combination. If there's only one factor, it's literally just the same thing as the levels. We also have this idea of a control group. This is a necessary piece of an experiment. You need a group that's given no treatment at all. You need a group that lets you see that whatever is going on, there's something to compare to. My example for this is a crazy coworker I had back when I was at UCSD. We had pizza one day because we had pizza parties all the time there to celebrate finishing that second round, that 5 years of testing. And so we're at the pizza party, and a different coworker who I liked was like, oh, I can't have pizza. Turns out I have dairy-induced earaches. This is literally what she said. I have dairy-induced earaches. And I, of course, being the wise guy that I am, was like, you're doing it wrong. You don't put the cheese in your ears, you eat it. But then my annoying coworker was like, oh, let me be helpful. I have oil of oregano in my office, and oil of oregano would totally help with your dairy-induced earaches. To which I turned and was like, how would you know this? Like, I've never heard of a dairy-induced earache before, and now you're all of a sudden coming up with a solution to a dairy-induced earache. So my example of why a control group is necessary would be, let's say instead of dairy-induced earaches, we had something that was a little more prevalent happening in our office. Let's say everybody was suffering from allergies. So if we all decided to use oil of oregano, we all believed my crazy coworker and tried oil of oregano, And a week later, we're all better. The question is it due to oil of oregano? And without a control, we can't make that statement, because what's another possibility for all of our allergies getting better? Well, it could just be that pollen levels went down, right? So if we have a group that has a treatment and a group that has a control, we could see, okay, oops, maybe the treatment group, they said their allergies got they went from a 10 and they went down 5. Where those people who were in the control, they went down 4. You go, okay, well, is that such a big difference? Nah, not that big of a difference. We don't think there's anything going on. But even if they both went down 5, then we just go, oh, something environmental happened. That's why it all went down. That has nothing to do with the oil of oregano. But if we don't have this control group, we may attribute all of that environmental stuff to the treatment as opposed to realizing it was environmental. As part of a control group, we may have a placebo, which I'm sure most of you heard of before. This is so that people who are in the control group don't realize they are in the control group, because there is something called the placebo effect. Where people will actually have a physiological reaction to thinking they are going to get better. So my coworker who just ate a bunch of 2-year-old lemon rind said she felt a lot better after doing so. And it might have just been the placebo effect, right? Who knows if it's these magical 2-year-old lemons, or if it's just, I did something that should help my cold, now I feel better. And the last definition here is blinding. Blinding is when people are unaware of what's happening in terms of who has the treatment, who has the control. Single blinding is when, as a patient or a subject, I am unaware of whether I'm in the treatment or the control, which again is necessary to fight the placebo effect. And then double blinding is when also the person evaluating me does not know whether I'm in the treatment or the control, because sometimes certain measurements are subjective and our internal biases can't help us from bringing that information in. So if there's anything subjective in terms of analyzing the outcome, we definitely want to use double blinding.